Namaskaram. Good afternoon all. Welcome to the teleconference program conducted by Department of Chemistry, Dr. B.R.Ambedkar, Open University. Today's topic is chemical kinetics. To explain this topic, we have two eminent personalities are here. Firstly, Dr. J. Mohan Babu, Assistant Professor, Department of Chemistry, University College of Science, Saifabad, Usmania University. Dr. M.Keshavulu, Senior Counsellor, Department of Chemistry, Dr. B.R.Ambedkar Open University, and also he is the Senior Lecturer in Biogenesis Institute. This program is of 60 minutes. In the first 40 minutes, we are going to discuss about the topic. The remaining 20 minutes will give you the time to ask any doubts or questions regarding the subjects. For clarifying your doubts, you can call to the following number 040-23680-456, or also you can chat in the live chat box and post your questions to clarify the questions by interacting with resource persons. Now coming to the topic. Our topic is chemical kinetics. This is the important branch in the physical chemistry. It deals with the investigation of reaction mechanisms by understanding the speed or velocity and what are the intermediate components involved in that reactions. Before going to the detailed discussion of this compound, first briefly understand the history of the development of chemical kinetics. This chemical kinetics first used by the Ludwig Wilhelmi in 1850 is studied on the inversion of sucrose by the acid catalyzed reaction. First he is used the rate of reaction in his investigation and proposed that the reaction rate is depends on the concentration of the reactants. Later so many scientists are working on it and developed so many advanced theories to investigate the known and unknown chemical reactions, to propose the mechanism by understanding the what are the type of intermediates, what kind of transition state involved in it, and what are the factors influences the rate of reactions, and what are the conditions we need to apply to get the product. When we coming to the application of chemical kinetics, these chemical kinetics are very important phenomena in our daily life also. For example, the kinetics is proposed for the understanding of reaction types. We generally see in several kinds of reactions: fast reactions, slow reactions, moderately speed reactions. For example, fast reactions. If you see the fireworks, whenever we see the fireworks, beautiful colors are appear by which a chemical reaction. That is a flash reaction, very speed reaction. The rate of reaction is very high. It is equal to 10 to the power of 35 rate, 35 speed. When we coming to this room, we have oxygen, hydrogen is there in the atmosphere. The reaction between the oxygen and hydrogen to convert into a water molecule, it takes years of or decades of time for complete the reaction. These are known as slow reactions. When you come into the moderate speed reactions, if you take food, you are eat some food, it will be digested by 30 minutes to 2 hours. That means the reaction is happen between the whatever the gastric juices and what you are ate. Therefore, the food materials are degraded by undergoing the reactions. Okay, and also when we coming to the industry, they can develop the new reactions by understanding, by maintaining reaction condition, time, pressure, everything. That is obtained by the applying the principles of chemical kinetics. And for drug development in the medicine or drug development process, if you take a medicine, what time it will be dissociated in the gut wall or in any other medium, introducing any medium, intravenous or oral, whatever it may be, how it is disintegrated in the animal body, how it is flow from one part to other part, how it shows the activity, what rate, what speed it will be happen, that is also the under the chemical kinetic principles. Now coming to the environment, we have so many pollutants are there, how they behave each other whenever they are collide to each other, they convert into harmful products, sometimes that may be destroyed the environment. Okay, these are all the factors or can be studied by using the chemical kinetics. When we can understand these phenomena can be understood by understand the basic concepts involved in the chemical kinetics and what are the theories involved in it, how these theories can be applied. For understanding, you can please follow this program. Just now I am going to ask the question first. Mohan Babu sir, please explain what is the rate of the reaction, explain the factors affecting on the rate.
Yeah. So rate of the reaction. So generally here the rate means the speed or the velocity of the chemical reaction. So before going to discuss the rate of the reaction, first we will see a chemical reaction, right? So what is an chemical reaction and what is happening in a chemical reaction here? So generally the chemical reaction means where the reactants converts into products is a chemical reaction. And what is happening in a chemical reaction? During this chemical reaction, what are the things takes place here? So here the reactants going to degrade, means where the concentration of the reactants is going to decrease and the concentration of the product is going to increase here. So this is happening in this reaction. So at what rate this reaction is taking place? Okay, so the reaction is taking place. For example, you take toluene or the methyl benzene here. When we are undergoing the chemical reaction, we will get a benzoic acid, for example. When you using some oxidizing agents like KMNO4 or the K2Cr2O7, so where this CH3 is converting into COOH. So methyl is converting into carboxylic acid functional group here, right? So this conversion done by what rate of the reaction, right? So how much component means reactant is going to convert at what time? So it will be explained by the rate of the reaction. And here question is all the reaction, means can we calculate the rate of the reaction for all types of reactions? So the answer is certainly no, right? So only a particular kind of reactions are feasible to calculate the rate of the reaction. As the Koteshwara Rao told, like here the chemical reactions are three types. One is very fast reactions, means very fast reaction means like you take precipitation reaction here, right? In the precipitation reactions, within a fraction of time the precipitation is going to form. Like you take one example like the silver nitrate when it is reacting with the sodium chloride, and silver chloride is a precipitation formed in this reaction, and sodium nitrate is a byproduct which is obtained in this reaction here. So this formation of this silver chloride precipitation takes place very rapidly. So for this kind of reactions we cannot calculate the rate of the reaction because all these are the very rapid reactions. And one more example like acid base reactions here. You take sodium hydroxide and treat with the HCl, you get the sodium chloride is a product here. So this salt formation, this is also going to form very rapidly. Okay. And you can take one more example like explosive reactions here, right? Explosive reactions are very fast reactions. So for all these kind of reactions, we cannot calculate the rate of the reactions. Okay. And the second category of the reactions are very slow reactions. So these are distinct to this particular fast reactions here. So very fast, slow reaction means like you take one example, right? So like formation of the coal or the formation of the diamond or rusting of the iron, right? So when you keep a iron in the open air here, so it will be going to form a rust in a lot of time. Means when you keep in the open air for a lot of times, then it is going to form the rust here. Okay, so this is taking a lot of time here. So this is very slow reactions. Or you can very famous example like degradation of the plastic here. You know that, right? So nowadays the plastic it is a very harmful pollutant here. So for the degradation of this plastic, so it takes 10 years to 1000 years here for the degradation. So this kind of reactions, for this kind of reactions you cannot calculate the rate of the reaction here. And the third category of reaction is moderate reactions. So moderate reactions, so these are not fast as your fast reactions and not slow than your like your slow reactions here. Okay, so it is moderate reactions. For this kind of reactions you can calculate the rate of the reaction here. Okay, now we will see what is a rate of the reaction. Okay, for example here I am going to Usmania University, for example, right? So I can go by various means, like I can go by walking, or I can go by cycle, I can go by two-wheeler or the three-wheeler or the four-wheeler. So these are the various facilities to go to the particular place here. For example, I move to that particular university, and for going to there, so it takes some time, like you can measure, okay, so how much distance is traveled by myself and what is the time taken for this movement of this one. So you can see, you can calculate this distance or the place by measuring that distance here, right? Because it is a physical entity, you can do that. But the rate of the reaction, right? So there is no movement of this one, because when you take a chemicals, when you take a reactants in a particular vessel here, in that vessel the reaction is taking place. So there is no particular movement or the migration or anything is not happening in this. So you cannot, and it is invisible reaction, isn't it? You cannot see that reaction taking place in the vessel. So it is invisible here. That's reaction. Why, yes, invisible reaction. So you cannot means tell the rate of the reaction by seeing that the vessel, isn't it? So we can calculate the rate of the reaction by following, means by seeing the, or by calculating the concentration of the reactants and the concentration of the products here, right? So like in the chemical reaction, what happens here, the rate of the reaction, okay, sorry, the concentration of the reactants is going to decrease here and the concentration of the product is going to increase. So how much concentration is decreased and how much concentration is increased of the product. So by seeing this, by calculating this, we can decide or we can calculate the rate of the reaction. So in this particular picture, you can see the picture here, right? So we have two graphs, two lines are drawn in this particular graph here. So if you see the red line, which indicates the product formation, concentration of the product formation, where the concentration is going to increase from 0 to a certain value, right, where the value is going to increase, because initially the value is 0 and up to time passing here, so where the concentration is going to increase and it is reaching to a maximum value here. And where the blue line, you can see where it is starting from the graph is starting from the higher to lower, okay. So maximum value to the minimum value. So the concentration is going to decrease for a reactant, right? The red line indicating the concentration of the product and the blue line indicating the concentration of the reactant here. So these two phenomena is taking place during a chemical reaction. Okay, and in this okay, and the expression of these chemical reactions, how to express this particular chemical reaction. So here the rate of disappearance of the reactant. Disappearance means where it is going to decrease here. Okay, so the rate of disappearance of reactant, that is calculated by taking the decrease in the concentration of the reactant by the time taken, right? That is called shown like minus delta R by delta T, minus delta. Why? So here we should use a minus value because minus indicates the decrease in the concentration of the reactant, right? And the delta, it is showing the difference of the concentration of the reactant at a certain time here. Okay, and the delta T, it is a change in the time. Okay, for example, in a 5 minutes time, how much concentration is decreased, how much concentration is decreased by the reactant here. Okay, so like that, from 5 to 10 minutes, how much concentration is decreased. So it is calculated by using this formula. And rate of appearance of the product, so it is calculated by doing this equation like increase in the concentration of the product by time taken. Here where the in this chemical reaction the product concentration is increasing, so we must show with the positive charge here, means plus charge. Plus charge indicates the increase in the concentration of the product. So the equation, the expression of this particular chemical reaction can be denoted by delta, right, in the square bracket P by delta T. So delta indicates the difference of the concentration of the product at a certain time intervals here. Okay, and the delta T, it is a time intervals. Okay, like T2 minus T1 or T1 minus T3. So like that, that is a difference of the time taken for the decrease or the increase of the reactants or the products of this particular chemical reaction. Now we are moving to this particular chemical equation here, right? So you can see how to write the chemical general rate of the reaction. Here we have some example is taken like chemical equation. Here small a of capital A plus b, small b of the capital B. These are the reactants going to form the products like small c and the capital C and small d capital D. Where the small a, b, c, d, these are the stoichiometric coefficients, and where the capital letters, these are the A and B are the reactants which are going to participate in the chemical reaction, and capital C and D is the products obtained in this particular chemical reaction here. Okay. Now how to write this particular rate of the reaction? So you can write this equation like here the rate of the reaction is equal to minus 1 by A delta concentration of the A by delta T equal to minus 1 by B delta concentration of the B by delta B. Okay. So here we use the negative charges here, negative symbols, not charges, symbols here. Okay, minus symbols. So it indicates the decrease in the concentration of the reactants, and here we are using the 1 by A, right? A is a stoichiometric coefficient here, and we use the 1 by A because to equalize the the concentration of the various reactants and the products, we use the 1 by, and to make the rate of the reaction component positive value, we write that particular 1 by A, 1 by B or 1 by 2 like that here, right? So this is the equation, and now we are moving to the types of reactions here. Here we have two categories of the reactions. One is average rate of the reaction and instantaneous rate of the reaction here. So what is average rate of the reaction and what is instantaneous rate of the reaction? So these are the two distinct terminologies here, where average rate of the reaction. Okay, so average rate of the reaction means Like here, for example, a chemical reaction is taking place, right? A chemical reaction is taking place by using the reactants. Okay, so we note down the reactants concentration for the time intervals like T1, T2, T3 here, right? So yet, and for last like Tt, right? So that is an infinite last time here. So how much time is taken to form a particular means a product, and what are the concentration decrease in the reactant. Okay, so the total time taking for this conversion, either increasing of the reactants increasing of the product concentration or the decreasing of the reactant concentration. Okay, so any one you can take to express the rate of the reaction here. Okay, so but here the average rate of the reaction means we can consider the time intervals for this conversion, either decrease or the increase. So we will consider the time interval from 1 minute to 5 minutes, how much, right, how much concentration is going to increase or how much concentration is going to increase of the product or decrease of the reactant here, right. So we are considering the time interval here. Okay, 1 to 5 minutes or the 1 to 10 minutes, like that here. Okay, it is a time interval, right. So now coming to this instantaneous rate of the reaction. So instantaneous rate of the reaction, we will consider a specific time, at a specific time what is the concentration of the particular reactant or the concentration of the particular product here, right. If for example the time for at 1 minute, what is the concentration decrease of the reactant, or at 1 minute what is the concentration increase of the product here. Means here a specific time is considered to calculate the instantaneous rate of the reaction. So this is the difference. For average rate of the reaction, we will consider the time interval from 1 minute to 10 minutes here. Okay, how much? Because it have the variation in the, right. At 1 minute, for example, here right, so 1 mole per liter per second. For 2 minutes it is 3 moles per second, so something. So we will do the average and we will get the value, right, conversion of the value. But here in the instantaneous rate of the reaction, at a particular time, what is the value? So there is no of the reactant, like the state of the reaction, physical of the reactant, like the state of the reaction, physical state of the reactant. For example, gaseous state. Okay, and in these three states, you know that the solid state where it is closely packed and the intermolecular is closely packed and the intermolecular forces are there. So where the rate of the reaction is more for the gaseous state, right. So here the nature of the reactant. So like in the solid substances, the rate of the reaction is less. In the gaseous substances, the rate of the reaction is more. And if any ionic substances are there where the rate of reaction is observed more, right, because it is in the ionic state. So the atoms are in the ionic state, so easily can react with the other substances here. If it is a covalent, okay, if it is a covalent substance, you know that covalent bond is very strong bond here. So to break down that covalent bond, so more energy is required. So the way you can find the rate of the reaction is less for this covalent substances. Now the second factor is the concentration of the reactant. So obviously where if the concentration of the reaction is increases, the rate of the reaction will be increases. Means the concentration of the reactant is directly proportional to the rate of the reaction here. And the temperature, here the temperature also directly proportional to the rate of the reaction. With increase of the temperature, the rate of the reaction is going to increase here. Next, substance surface area, right, substance surface area. Surface area means the outer sphere of the substance or the material here. Okay, so if the surface area is less, okay, surface area is less, then where the rate of the reaction is more here. Sorry, the surface area is more, the rate of the reaction is more. Means it is directly proportional, right? If the surface area, with increase of the surface area, the rate of the reaction is going to increase here. Like here the size, okay, particle size is less, then surface area will be more and the rate of the reaction will be more. For example, you take right, you two kind of substances, like you are taking the medicine one, right? You take the drug, one tablet you are taken and you dissolve in the water, right? In the same amount of water, volume of water, you are dissolved, you make that tablet into powder and you make into dissolve in that particular solvent here. Then you tell me which one is going to soluble easily. So
Rapidly.
the powder, okay, the powder is going to soluble very easily because it is, right, converted into the small particles here. So for the small particles, the surface area is, means the intact area of that particular particle is more here. So it is easily soluble in the solvent. So like that, the rate of the reaction is more for the substances size is less and the surface area is more. Okay. So these are the factors which is affecting the rate of the chemical reactions.
Okay, sir. Right. The rate of reaction is directly proportional to the concentration of the reactants, or sometimes we can express it decreasing the concentration of the reactants or increasing the concentration of the products. And several factors may influence the velocity or speed of that reactions. Now I am asking Keshavulu sir, explain what is order of reaction, explain various types of reaction with different orders, and how we can determine these orders by using several methods. Please explain this.
Yes, sir. Whenever the reaction is carried out, the reactants are converted to the products. How we are going to find out the rate of the reaction? As sir said, the concentration of the reactants are decreasing, the concentration of the products are increasing. This decreasing phenomenon and increasing phenomenon with respect to time. So means as the time is going on, concentration of reactants are decreases, concentration of products are increases. With respect to that, we are going to find out the rate of the reaction. So any reaction we may consider the reactants are converted to the products, but the rate of the reaction is always directly proportional to the concentration of the reactants. What kind of reactants we are utilizing, how they are converted into the products by involving in various steps and various mechanisms. In that, the rate of the reaction is directly proportional to the concentration of the reactants. So for a general case, rate of the reaction is X moles of A reacts with Y moles of B, that can convert it into products. Therefore, so in this particular reaction, the rate of the reaction is directly proportional to concentration of A power X, that is the coefficient of X of reactant A, and the concentration of B power Y, that is the coefficient Y is concentration of B. So these are the A and B, capital A and B are the reactant molecules whose coefficients can be written as the powers. So anyhow, the proportionality can be removed with the help of some constant. This is K becomes rate constant. So rate equation we may call as rate of the reaction is equals to some rate constant into concentration of the reactants, and whose powers will be taken as whose coefficients will be taken as the powers. Right. So then when the rate constant is equals to rate of the reaction, so we are going to discuss about the rate constant means that can be replacing with proportionality. So how that proportionality will be equals to rate constant, that rate constant will be equals to rate of the reaction means the reactant concentrations must be considered as unity. If both the reactants A and B are considered as unity, so that means concentration will be expressed in terms of moles per liter. Therefore, concentration of A is 1 mole per liter, concentration of B is 1 mole per liter. Therefore, hence the rate of the reaction is equals to rate constant. This rate constant how we have replaced with proportionality when the rate of the reaction is directly proportional to the concentration of the reactants. So the rate equation means the expression of rate of the reaction in terms of concentration of reactants with the help of rate constant, that is called rate equation. With the help of rate equation, whatever the reactant molecules are involved in the reaction, so the order of that reaction we are going to find out, right? So then coming to the part of order of the reaction, there is some example is there, reaction, general reaction, A moles of reactant A plus B moles of reactant B converted to C moles of product C and D moles of product D. So in which the rate is directly proportional to the always concentration of the reactants and whose coefficient will be taken as powers. So those powers, sum of the powers of the concentration of the reactants which are involved in rate equation, that will be considered as order of reaction. If the reactant power becomes 1, that is called first order reaction. If the reactant powers will be 2, that becomes second order reaction. Reactant powers will be 3, that is the third order reaction. If that reaction will be happen, the rate of the reaction is independent on concentration of the reactant, so that we may call as zero order reactions. So hence the sum of the power of the concentration of the reactants which are involved in rate equation, that is called order of the reaction. For this particular reaction, so order with respect to A, that is equals to A, right? X is the order of the reaction with respect to A, that is the A power x will be there. Here if the coefficients are small a and small b, here we use it to small a and small b. So here x and y will be there. Therefore x is the order with respect to reactant A, then y is the order with respect to reactant B. Both A and B reactants are involved in a chemical reaction. Therefore the overall order of the reaction will be sum of both orders with respect to A and B, that will give the overall order of the reaction. Hence the overall order of the reaction will be x plus y. The order may be 0 for the reactions, that may be positive value, that may be negative value, that may be fraction
value.
Right? All the possibilities are there for order of the reactions. So whether the reaction is carried out, reactants are converted into the products, then we are going to say order of the reaction will be 0. Means in that particular reaction, rate of reaction is independent on concentration of the reactions. What is meant by 0 order means the rate of the reaction is independent on concentration. So such reactions are called 0 order reactions. Any photochemical reaction we may take, so the reactants are converted into the products in the presence of light radiation. So therefore the rate of the reaction is depends on the light radiation only, irrespective of the concentration of the reactants. Such reactions are called as 0 order reactions. And even decomposition also we may consider, right? So the order may be positive 0. 0 means decomposition reactions, the simple decomposition of ammonia. Ammonia gas will be decomposes into nitrogen gas and hydrogen gas. In this, during the decomposition process, the rate of the reaction is independent on the concentration of the ammonia. Hence such reaction is example for the 0 order reaction. When first order, second order, third order means positive order will be there. For the positive order reactions means, say simple example, hydrolysis of methyl acetate will be there, right? So that is followed by pseudo first order. So we will discuss about the pseudo first order, means that is example of first order. Then second order means decomposition of HI. 2 moles of HI will be decomposed into hydrogen and iodine. So that is called second order. So when we are getting the fraction of the reactions means somehow simple reactions are there, somehow complex reactions are there. What are meant by simple reactions? The reaction which will be takes place in a single step, that is called simple reactions. Complex reactions means the same reaction will be followed in many number of stages or many number of steps. For example, one hydrogen bromide process will be there. Hydrogen and bromine will be converted into HBr, that will be involved in various stages. So that may follow a chain reaction. So therefore hence in that the concentration of the reactants not we are taking directly. So therefore that will be based on the concentration involved in the rate determination step. Therefore that may follows fraction order. So then any reaction is there, nth order means the units of rate constant will be expressed for all the cases. So for the nth order means n moles of reactant A is converted to the product. For nth order, the rate constant units are concentration power 1 minus n and time universe, because concentration, change in concentration of reactants with respect to time, or change in concentration of products with respect to time. Therefore concentration changes will be there. For the nth order, we will get from that, we will get the units of 0 order kinetics, first order kinetics and second order kinetics. For first 0 order kinetics, moles per liter per second. Then for first order kinetics, only per second if the reaction will be carried out in seconds. If the reaction is carried out in minutes, minute inverse. If the reaction is carried out in hours, hour inverse. If the reaction is carried out in days, that is day inverse, right? So therefore the second order rate constant units are per mole, liter and per second. This is the units of rate constants. Then coming to the part of molecularity of the reaction, means how many molecules which are involved in the reaction. We are going to find out the order of the reaction. So during that order of the reaction, how many number of reactant molecules are involved in that reaction, whether it is a simple reaction or whether it is a complex reaction. So therefore based on that, so we will get in a simple reaction, so how many number of molecules are there, so that will be considered as its molecularity. So in case of ammonium nitrate, so that decomposition of ammonium nitrate will produce nitrogen and water. So only one molecule of ammonium nitrate is involved, therefore unimolecular reaction. So in simple reaction, HI will be dissociated into hydrogen and iodine. So therefore 2 molecules of HI will be involved, therefore that is bimolecular reaction. So in the case of next nitrous oxide react with oxygen produces nitrogen dioxide, 3 molecules are involving. This is happened in case of simple reactions. If it is a complication reaction, so out of all the reactions, which reaction will be slow reaction, means the reaction will be carried out in 4 stages. Out of 4 the stages, which step is a slow step, that is called as rate determination step. Therefore hence the rate of the reaction is depends on the rate determination step. How many number of molecules are present in the rate determination step, so that will give molecularity. So if you may go the difference with molecularity may not be 0, because 0 molecules are not involved in a chemical reaction, definitely molecularity will be positive. So it is not a negative, not a fraction and not a 0. So but order is 0, positive, negative and fraction also, right? And particularly here we will get the molecularity of the reaction, means that is the theoretical concept, then order of the reaction is experimental concept. Order of the reaction is experimental concept. So this is the difference between the order and molecularity. So whenever both order and molecularity are not equal, such reactions we may call as pseudo first order, pseudo order reactions. If molecularity and order does not equal, such reactions are called as pseudo conditions. Whether so it is a first order, pseudo first order, it is a second order, pseudo second order, like that. So then coming to the part of, so how the rate of the reaction is carried out for the 0 order reactions. As I said, 0 order reactions, the rate is independent on the concentration of the reactants. Therefore the reactants are converted into the products. So therefore we will get the rate of the reaction, that is K rate constant for the 0 order reaction, K is equals to, so concentration of reactant change with respect to time. So that is the example for 0 order reactions are decomposition of ammonia into nitrogen gas and hydrogen gases. So if you may consider the plot, right, so as the time is going on, the concentration of the reactants will be decreases, right. So then coming to the part of first order reactions. First order reactions means only one molecule is involved in the reaction, so that can be converted into the products. So then for the rate of the reaction is depends on the concentration of the reactant of that one molecule only, therefore order of the reaction will be considered as first order. So the example for first order reactions, decomposition of N2O5. So N2O5 is decomposes into N2O4 plus half O2. Only one molecule is involved, hence the rate is depends on concentration of that N2O5. So therefore that is called first order reactions. So how we are going to confirm that first order reactions, even with the help of examples also. If one reactant is there, so as the reaction is going on, we are able to get some rate constant of that reactant. So with some concentration. If we may double the concentration, the rate constant also will be doubled. Whatever the rate we get in the previous session, so that will be doubled in the next section. Means as the reactant concentration will be double, the rate also will be double. Hence that reactions are called as first order reactions, and the first order reaction equation can be denoted with K is equals 2.303 by T log, so A by A minus X, or reactants of remaining reactants with respect to the concentration of the reactants after formation of products, right. So then coming to the part of half-life of reaction. What is meant by half-life means whether the reaction is carried out in a certain period of time, half of the reaction is completed in how much time. Suppose the reaction is carried out in 1 hour, so means up to 30 minutes, how much reaction is completed. So that is the 30 minutes means half of the time of the reaction, right. So means whatever the initial concentration is there, half of the initial concentration is converted to the product. At what time, that condition is considered as half-life of the reaction. As we summarize both all 0 order, first order and second order reactions, for 0 order reactions which are directly proportional to the initial concentration, and first order reactions are independent on the concentration of the initial reactants, then second order reactions are inversely proportional to the initial concentration of the reactants. So the half-life reactions will be denoted with T half is equals to for 0 order R naught by 2K, and T half for the first order, that is 0.693 by K. So that means there is no initial concentration in that equation, therefore hence the first order reactions are independent on initial concentration of the reactions. Then so pseudo order, as I said, the best example for pseudo order, that is hydrolysis of methyl estate, that will be carried out in the presence of acid, right, that will be converted into acid plus alcohol. So here two reactants are there, ester is there and water is there, but the rate of the reaction is depends on only ester irrespective of the water in the form of excess. So therefore hence two reactants are there, but the rate is depends on only one reactant, hence order and molecularity are different. Such reactions are called as pseudo first order reactions. As Sir said, so decomposition means conversion of sucrose into glucose and fructose, right? So that hydrolysis of sucrose also can be follows pseudo first order kinetics, right? There are various methods are there to determine the order of the reaction. So somehow we summarized that are integrated method and a graphical method and so initial rate method and a half-life period method. These are the methods are used to measure the order of the reaction. So here, so that will be summarized for zero order reaction. The integrated rate equation will be A is equals to A naught, means initial concentration minus KT. But so for first order reaction, that is A is equals to A naught into e to the power of minus KT. For second order reaction, A is equals to A naught by 1 plus K plus A. These are the integrated rate laws. So that applicable for the zero order, first order and second order reactions. This is the integration method to get the order of the reaction. So there are various graphical representation for the first order, zero order and second order. So what is the zero order means? The concentration versus rate, if you may consider, rate is independent on the concentration of the reactants, hence that will be parallel to the x-axis only. Therefore the first graph this indicates the parallel to the x-axis, means this rate is dx by dt is the rate which is independent on concentration, hence this is called zero order. If the concentration and rate, that will give passing through origin, as the concentration increases, rate also increases, that is called first order. If we take concentration squares, means that is second order versus rate, that is also give straight line passing through origin. So like in case of concentration of reactants versus time, so that will be decreasing in case of zero order reaction. Then concentration of time, log concentration versus time in first order, that is also decreasing. Then time versus 1 by concentration, that will be increases with some intercept, that is in second order. So these are the representation of graphical representation of zero order, first order and second order, and the various methods which can be used to identify the order of the reaction.
Okay, sir. Now, for after discussing the order of reaction and rate of reaction, we need to analyze or we need to study the reactions. What are the factors which are influenced on the reactions, how they can be analyzed, and how they can be quantified. That can be studied by applying the various reaction kinetics theories. We have several theories are there, in which I am asking you, Mohan Babu sir, please explain Arrhenius theory of chemical kinetics, how it is useful for the studying the chemical reactions, the rate of reactions, or whether the mechanism of the reactions.
Yeah. So Arrhenius is one of the famous scientists, which is proposed a equation called the Arrhenius equation, and this expression, it gives a relation between the temperature and the rate constant and the Arrhenius constant here, right? So the Arrhenius equation is, here is the natural logarithm ln k equal to Ea by RT plus ln A. So here the ln k is a rate constant, right, the logarithm of rate constant here, and Ea is a activation energy, and R is a gas constant, and T is the temperature, right, the temperature required for the particular collision of these molecules here, and A is a Arrhenius constant, okay, pre-exponential constant or Arrhenius constant, we call that, that is any name for this one. Okay. So here this equation, Arrhenius equation, it tells about the relationship of the temperature with the activation energy and that particular Arrhenius constant here. Okay. So here when we draw a graph by taking this one, right, so we get this particular the graph which is right showing that the plot between the log k is a rate constant, log k versus the 1 by T, where the inverse temperature here, 1 by T is the inverse temperature, and we get the straight line, okay, the negative logarithm, because it is when you apply the slope, okay, y equal to mx plus c, but here we have that in this equation negative value. So y equal to y is a k, okay, ln is a mx, and c is a Ea by RT. So where Ea by RT it is having the negative value, so we get the negative plot in this particular graph here. Okay, so it tells the relation about the temperature and the activation energy and that particular rate constant value here. So when we are taking the two systems, here, like with two different temperature, right, like T1 and T2. Here at temperature T1 we have the equation ln K1 equal to minus Ea by RT1 plus ln A, and at temperature T2 here, okay, we are seeing the two different systems. Okay, so ln K2 equal to minus Ea by RT2 plus minus Ea by RT2 plus ln A. Okay, so we can calculate the temperature difference required for these two systems by calculating a common equation, right, that is log K2 by K1 equal to Ea by 2.303 R, right, 2.303 R, that equal to T2 minus T1 by T1 into T2. So means for derivation we get the final equation of this one. By using this formula you can calculate the temperatures required for a particular system here, and you know that the effect of the temperature on a chemical reactions, as in the beginning I told you the effect of the temperature on the rate of the reaction. So generally the rate of the reaction is directly proportional to the temperature, or temperature is directly proportional to the rate of the reaction. Means with increase of the temperature the rate of the reaction is going to increase here, and in general with increase of the 10 degrees of the temperature, generally the rate of the reaction becoming the doubled here. Okay, so we can see the effect of the temperature with a graphical presentation for the two systems here, right. Here you see that in the y axis where we are taking the number of molecules, and in the x axis we are taking the kinetic energy. Okay, the kinetic energy means the where particular molecule is having that energy, right. So to convert into the product, so it needs energy, right, and by taking that energy it is going to cross the energy barrier and it is going to convert into product. So that is activation energy, isn't it? So you can see the relation between the two systems, where here the green line, okay, so where the particular system T1, when you apply the T1 temperature here, so where its value is going to more, isn't it? Then in the red line you can see where the activation energy decreases, right, and where the kinetic energy is going to, right, it is increasing here and the activation energy is decreasing here, right. So you can compare the two systems by this graphical presentation. Now the effect of the activation energy and the catalysis here. So what is the effect of the catalyst in this particular rate of the reaction? You know that the catalyst which is involved, right, which is increasing the rate of the reaction without consumed in the reaction, isn't it? It won't consumed in the reaction, but indirectly it is responsible for the increase in the rate of the reaction. That is a catalyst here. and you know that the catalyst always it is providing the surface area for the better it means better reaction here, and it is lowering the activation energy, and it is making the same products here. Okay, and you know that very good example is the enzymes, right? Enzymes are biocatalyst here. So in the all the metabolic reactions or the biological reactions takes place in the presence of enzymes here. Okay, so here the enzymes are acting as a catalyst, right? And we can see the two distinct reactions with the catalyst and without catalyst. So a graphical presentation you can see in this particular graph here, right? You can see in this particular graph you can see that the red the red peak, it is showing that where you can see the higher activation energy
Without catalyst.
right, without catalyst. We are not using any catalyst here. So obviously its activation energy is more to convert into the product, where the ozone is converting into oxygen, okay, in this particular reaction. So without catalyst, where the conversion of the oxygen, it is requires more activation energy here. And the yellow line you can see the yellow plot, right? So where very less activation energy is required, means here the catalyst decreasing the activation energy for the formation of the oxygen from ozone here. So this is the effect of the catalyst and the effect of the temperature on the rate of the reaction. In both condition where the rate of the reaction is
Hello.
Hello, good afternoon, sir.
Good afternoon. చెప్పండమ్మా.
Sir, how to find the units of order of the reaction, sir?
How to find the units of order of reaction?
Yes, sir.
Okay, can you answer?
Yes.
Sir, Keshav sir?
Order of the reaction. Rate of the reaction is directly proportional to the concentration of the reactants. So therefore, rate equation means rate is equals to rate constant into concentration of reactants. So what the power of the concentration of the reactants in rate equation? So that is called order of the reaction. So for example,
మూడు ట్యాప్.
right. So for example, if the reaction is carried out, A is gives rise to products. So how we'll write the rate of the reaction? Rate is directly proportional to concentration of the reactants. So this will be rate is equals, that proportionality can be removed with some constant, that is K. This is the rate equation. In this rate equation, the concentration of A power is 1. Hence this is called order of the reaction. So for any equation is there, so with a different kind of coefficients, right? So n moles of A plus n moles of B gives rise to products. So therefore, what is the rate of the reaction? Rate is directly proportional to concentration A power A and concentration of B power M, right? So therefore, the rate will be equals to concentration of A power M and concentration of B power N.
Units.
Rate is directly proportional to. Therefore, there N plus M, that is equals to order of the reaction. Any reaction you may take, the powers sum will be, so the powers sum will be considered as M plus N will be order of the reaction.
Units.
And units will be, so for nth order reaction, so moles per 1 minus N, liter power 1 minus N, sorry, one sec. Moles power 1 minus N,
Maximum.
liter power, right. Moles power 1 minus N, liter power N minus 1, second inverse. This is the common units for any order of the reaction. If this is 0 order, N is equal 0, we have to substitute. Therefore, what will get? Moles power 1 minus 0 means moles, then liter power minus 1, second power minus 1. This is 0 order. If N is equals to 1, we have to substitute. That is the first order. 1 minus 1, moles power 1 minus 1 means something power 0 is 1. Liter power 0 is 1. Therefore, that is the units are second inverse only. If N is equals to 2, we have to substitute. That is moles power 1 minus 2 means minus 1. Liter power 2 minus 1 means liter. Then second inverse. So this is the equation for any kind of reaction. We will get the rate constant units.
Okay, presentation continue. Right. Is it power, sir, or Arrhenius theory? Can you continue to collision theory, sir? Just brief it,
Yeah.
1 minute.
So just collision theory means whenever we are going to discuss about the reactions, the reactant molecules are collide with each other. When the molecules are collide with each other, they acquire some energy. So means that will be reaches to the energy barrier. For any reaction, some energy barrier will be there. Those reactant molecules are acquiring their energy with the help of collision. So with the help of collision, the molecules are acquiring energy that will be reaches to the higher energy level. Then from that will be converted to the product. So means the reactant molecules definitely cross over the energy barrier to conversion of the products. How many number of molecules are cross over the energy barrier? So that are only responsible for the formation of products. So what are the molecules are involved in the collision? So that are responsible for the formation of products. So that are called fruitful collisions or effective collisions or active collisions. So with the help of that active collisions frequency, that is called as collision frequency, therefore rate is directly proportional to the collision frequency and also energy barrier. With the help of that sum, that we will give the rate of the reaction in collision theory. Coming to the part of transition state theory, any reaction is directly cannot be converted into the products. In between some higher energy state will be there, that is we may call as activated complex. So the reaction may proceed via a activated complex. Activated complex is not an intermediate, we cannot isolate that transition state. So with the help of that we will get, with the help of activation energy, the rate of the reaction will be very high, rate of the reaction will be very low. So all such things will be explained with the help of transition state theory. So here we may use some Eyring equation. So that equation can be helpful to explain the rate of the reactions with that, whether that are directly not converted into the products.
Okay, sir. Now this, when after our discussion all these things, we came to the conclusion, chemical kinetics. After hearing all the discussions, chemical kinetic is an important phenomena in physical chemistry to understand the pathways of the reactions and propose the mechanisms and proving the mechanisms based on the, by studying the rate of reaction. Once you study the rate of reaction, you can classify the reactions into whether it is the 0th order reaction, 1st order reaction, 2nd order reaction or nth order reaction. After classifying these order of reactions, and also you need to study about the what kind of factors influencing the rate of reactions, how they are affecting, how these factors affecting to produce the product, to complete the reaction, and what we need to take the necessary action to complete the reaction. After studying the chemical kinetics, we can understand all these things. Therefore, these chemical kinetics phenomena or theories can be implemented to study the or fixing the or finishing the products in the pharmaceutical industries, like making the high yield products by using the good established reactions. After that, we are using in the drug development, how to prepare the drugs or medicines, what size particle need to be there in the drug, how this particle will be associated or interacted with the biological body. After that, how it is reaching to the target, after reaching to the target in the receptor, how it is acting. Later we are studying about the environmental effects, like that. Okay, in several ways chemical kinetics is useful. Therefore, we studied about this. Thank you for patient listening.